Good evening. I'm Will Gottschalk, and these are my partners, Aamir Husain and Leo Parsons, and together we are Techtiles, a measurement system in clothing. So the wearable technology market is expanding rapidly. Right now, it has a current market value of roughly $7.1 billion, and that's projected to grow to $12.6 billion by 2018 alone. That's a 77% increase in 3 years.
Some of the current products that you might actually be familiar with and more popular in the market today are things like Hexoskin, Fitbit, and the Apple Watch. Hexoskin is actually a recently released product to the market that's somewhat similar to Techtiles in design. However, they have limitations such as they do not offer activity monitoring. When comparing to the Fitbit and the Apple Watch, here's two of the more popular designs and products on the market today. However, they yet are able to incorporate respiration rate as well as offer a few inaccuracies in their data. Techtiles implements a full one design that brings all these readings together. And we're actually going to show a little video of our design. So I apologize for the blurriness of the numbers here, but I'll try to walk you through them. So here's Aamir just taking his daily stroll through the George Washington campus. So if you can notice the step count here, it varies with him walking in increments about 8, and then we cut to a new spot. But the data is constantly refreshed by 3-second intervals, and then the respiration rate and heart rate refreshes every 15 seconds.
All right, so the way Techtiles works is pretty straightforward. The user first plugs in their processing unit into the shirt, and then they put the shirt on. And then next, all they have to do is upload the application on their phone, sign in, enter their height and weight, and Techtiles immediately starts talking with the Bluetooth module and sends data wirelessly. So how does this thing actually work? We use 3 different sensors to get all of our information. The first was an ECG, which measures heart rate. The second one is a stretch resistor, which is able to measure breathing rate. The third one is an accelerometer, which is able to calculate steps taken, distance traveled, and energy expended. So what really makes this shirt unique, though, is the materials that go into the actual stitching and the fabric. We decided to use silver-coated nylon fabric for the electrodes and the stretch resistor, and we also use stainless steel thread for the wiring. This gives us 2 distinct advantages. The first one is that it is highly conductive, and it is also low in resistance. So stitching it into the shirt will not affect the signals coming through. The second advantage is that this makes the shirt completely washable. If the housing is disconnected, everything is still fabric. It can be thrown in the washer if it gets dirty, and none of the electronics will be destroyed.
So I'm going to talk a little about the algorithms we actually use to calculate this data. So we use predefined thresholds to actually, from the incoming data, to calculate heart rate, respiration rate, and steps taken by the user. Energy expended was actually calculated from a data set relating calories burned and speed for varying weights. And distance traveled was determined based on user step count data and their stride length based upon the height that they entered into the app.
That data is then received to the actual Android mobile device via Bluetooth connectivity. That data is then also analyzed and displayed in user-friendly format. Here you see our main profile page on the app. It offers 5 readings of distance traveled, number of steps, calories burned, as well as breaths per minute and beats per minute.
Okay, so our project started off as a simulated schematic, and then we ported it onto a circuit board design program before we actually went ahead and manufactured it. So we went through a bunch of different iterations just to make the components as small as possible. Our first board was very clunky. It had through-hole components, and it was just something that you wouldn't want to wear. So we went through a bunch of different revisions, made everything as small as possible. That's our final schematic up there. After that, we went ahead and customized a housing, which includes that board, the battery, and a charger, as well as an on-off switch. And we went ahead and 3D printed it over here on campus. And so you can see right there, that's the final product. It's about the size of an Altoids tin. I actually have it right here. just so you can see it in person. And that contains, we have the connectors for the shirt, and inside we have all the components.
So with wearable technology, the market expanding, more and more individuals are more concerned with monitoring their physiological signals. So not only is Techtiles applicable to athletes, but there's also several other practical applications. One application I'm going to talk about is actually military. So based upon a soldier's heart rate and respiration, decisions can be made by higher-ranking officials to delegate resources accordingly and perhaps save that soldier's life.
Just a few of the future advancements that Techtiles has considered. For implementing into our hardware, we would look for a more sophisticated ECG, smaller housing, less wires. In regards to the programming, we look for a little bit more of a robust algorithms for higher accuracy, as well as applying some sleep monitoring applications. With the actual mobile application, we could look into further history, as well as analytics, and maybe even into some social networking capabilities.
And so before we conclude, we'd just like to thank our mentor, Dr. David Nagel, who is in Japan right now, so he couldn't make our presentation. But we'd also like to thank our TA, Brandon Bernier, and the GWEC department for helping us make this project a reality.
Questions? Okay.
The current ECG system requires you sticking the sensor to the skin in various places in the chest. How does your system work?
So the question was, how do we determine the placement of the electrodes, and how do we attach it onto our shirt? Yeah. So on the body, correct. So we determined through the different lead setups what would be the best way to get a readable heart wave using as little amount of electrodes as possible. So we only use 2 leads. We did some research. We figured out having 2 at the top of the torso and 1 on the bottom right-hand side gives us the best reading for what we need to determine heart rate. And it's stitched into the actual shirt in areas which have pretty much the least amount of movement when you're walking around, just so that we can ensure that we get as good of a reading as possible.
So my question is related to that one. So are you just getting heart rate out of the ECG? Because it seems to me like ECG is something your competitors are not measuring, at least many of them are not. So it seems to me like if you were getting more information from your ECG, you might be able to do something with it other than just measure heart rate.
Yeah. Oh, sorry.
Or if you're only going to measure heart rate, you could use something smaller and simpler like
a pulse ox or LED was something that we thought about. And after doing our research, it's not something that would work properly if it's mounted on the torso. You need an extremity for that to work properly. And since that wasn't the goal of the project, it's something that we decided not to go with. As far as what else we could measure, the waves that we get right now, they're pretty much optimized to identify the QRS complex in the PQRST wave, which is that distinct peak that you see. So as far as reading other information, improving the circuit might be able to let us read different information from the ECG, but for now we only use that part of the wave to determine a heart rate. So we just measure the interval between that and through our algorithms and get our beats per minute through that.
When you mentioned social media, did you consider personal privacy in these things that maybe people wouldn't want this data shared?
Yeah, so for social media, within the app, the beginning of the application, there's a user profile. It requires password, username, it requires a login every time you go on. If we incorporate social media, which is mainly because a lot of competitors do that, a lot of people want to be able to kind of share with their friends, but it also comes with their social media, security preferences and all. You don't have to compete with your friends. You're not just saying, if I log in here, everybody can see what I'm doing with my activities. That's a complete preference, and we'd have into our settings whether you actually wanted that feature or not.
Thank you. Oops.
Did you talk to military yet? To military folks?
We have not.
But how do you encourage you guys to do that?
Yeah.
There are plenty of options. So let's talk options.
Thank you.
Thank you.
Great. Thank you very much.
Thank you.
Thank you.
Clicker. Need the clicker.
Second place award goes to Aamir Husain, William Gottschalk, and Leo Parsons of ECE for their project entitled Techtiles, a Physiological Measurement System in Clothing. Please come forward. Aamir, William, and Leo will receive $600 plus an additional $100 because their project has also been deemed patentable. So congratulations.